As we have learned, CAM software is an important piece in advanced manufacturing. In the next few videos, Michael Taylor, a machinist and educational assistant at the MMRI, will take us through a comprehensive understanding of Mastercam.
If you watched the previous Introduction to CAM video, or if you have a background in manufacturing, you'll likely already know that Mastercam is one of the biggest players when it comes to CAM software. Mastercam is the original CAM software package. CNC Software Incorporated, the parent company of Mastercam, was founded in 1983 in Massachusetts, USA. Since then, Mastercam has risen to become the largest name in CAM software. Another thing that makes Mastercam impressive is the fact that it was designed from the ground up as a CAD-CAM software package. As a reminder, CAD stands for Computer Aided Design, which is the drawing and modeling portion of CAD-CAM software. So unlike most CAM packages, which are merely add-ons to well-known CAD programs, Mastercam stands on its own with no integrations needed. Since Mastercam is a CAD-CAM software package, it can be used to create 2D or 3D models, or it can be used to generate the G-code necessary to manufacture the part on a CNC machine. In most cases, of course, these features are used in conjunction with each other. Let's consider quickly the process you would take from beginning to end when using Mastercam to create a program for manufacturing a part. A 2D wireframe is often the starting place of a project in Mastercam. From there, it can be fairly easily turned into a 3D solid model. Since Mastercam also has built-in drafting functions, after a model is created, you have the option of creating an engineering drawing of the part. Next comes toolpathing the part. Toolpathing is the process of defining the cutting paths that individual tools should take as they cut the part out of a piece of material. Once this step is completed, the next thing you would want to do is simulate the cutting of the part. The simulator can often present mistakes you made in your toolpaths and allow you a chance to fix them before using the program on an actual machine. One particularly useful feature of Mastercam Simulator is the compare function. Provided that you've created a 3D solid model of your part, Mastercam is able to compare the simulated toolpaths to the original 3D model and bring to your attention any details that do not match up perfectly. This is a very useful troubleshooting step and will save you a lot of headaches. Once all the back and forth with the simulator is finished, it's time to post the program. Posting is the process of converting the toolpaths that you've created into G-code. Once the program is posted, it will now be either a TXT file or an NC file, depending on the post setting you used. This new file is now typically put onto a flash drive and brought to the machine that will manufacture the part. And that brings us to the final step of the Mastercam process, manufacturing. It's finally time to see if that program you made works or not. If you did your job properly, you should soon have a finished part to show for your hard work. To conclude, let's briefly consider some of Mastercam's key features that make it such a powerful piece of software. Firstly, Mastercam is very user-friendly. If you're accustomed to using Microsoft Office or Google's equivalents, then you'll feel almost immediately at home with Mastercam's interface. It takes a familiar approach to menus, tabs, and buttons, making navigation quite easy. Another thing that Mastercam does to help out the user is sort the types of machines that you can create programs for. Rather than just having a giant mess of all the available toolpaths within Mastercam, they're broken down into machine presets. When one of these presets is selected, all of the relevant toolpaths to that machine will be displayed, allowing you to start selecting the most appropriate ones for your part. Mastercam is also a very heavily customizable program. Basically, any key binding, shortcut, color setting, menu, or button can be changed to suit your style. This allows for a highly customized user experience. Mastercam is also fully 2D, 3D, and multi-axis capable, No matter what complicated part or feature you're trying to create, you can pretty much guarantee Mastercam has a toolpath that can cut it. Next, we'll consider Mastercam's drafting features. While it's true that Mastercam's drafting system is not the most powerful solution for creating engineering drawings by any means, what it definitely is convenient. It might be preferable to use a purpose-built drafting program like AutoCAD to create the most professional engineering drawings. But if you just need a working print for reference or manufacturing purposes, Mastercam's built-in solution will definitely get the job done. Finally, one more area that Mastercam really stands out in is its simulator. As we've already begun to discuss, Mastercam's simulator has a multitude of settings and checking tools that can be used to verify the effectiveness of your program that you've created. These tools will help you to save countless hours of time that could easily be wasted going back and forth from the manufacturing and programming stages of developing a working program. The simulator effectively eliminates that wasted time by allowing you to catch silly or serious mistakes before running your program on a physical machine. And trust me, crashing the simulator is far preferable to crashing an actual machine. If Mastercam has caught your interest, then why not check out our next video in the Mastercam series as we begin to walk through each part of Mastercam in much greater detail and take you through the process of creating programs for yourself.